Hello, everyone, and welcome. It's Sean Barry here once again from SatCan, and I'll be joined today by Stephane Germain he's the CEO and president of GHGSat. GHGSat and family save the world is the theme for today, and we'll get into why I say the GHGSat family. You've maybe heard of Claire, Hugo, and Iris. I want to talk about all that stuff. But I'll tee it up really quickly by just saying, if you have any questions, please use the chat feature on the right-hand side of your screen. You should see in the bottom of your screen, you'll have a chat button. You can ask a question in there. I'll look at the questions and I'll moderate them and I'll toss them up to Stephane. That just saves time and from people talking all over each other in the meeting that we're in. So save those questions and put them in the chat feature and I'll make sure that he gets them. And please stay muted throughout. Not that I don't want to hear your voice, but it just keeps things a little bit cleaned up for the broadcast. Talking really quickly now, methane emissions have doubled in the last 70 years, according to the New York Times. Got a quote here, quote, methane emissions from oil and gas operations have consistently been found in research over the past several years to be far higher than the industry and the Environmental Protection Agency were estimating. Bloomberg goes on to say, and I quote, detecting methane emissions has been a challenge in the past because they are mostly caused by hard to detect leaks. But over the last few months, and Stephane would probably laugh at that, over the last few months, new satellites have provided a way to identify large discharges. Why does it matter? In the first 2 decades after its release, methane is 84 times more potent than carbon dioxide. While methane doesn't linger as long in the atmosphere as carbon dioxide, it is initially far more devastating to the climate because of how effectively it absorbs heat. Because methane is so potent, and because we have solutions that reduce those emissions, addressing methane is the fastest and most effective way to slow the rate of warming now. That's from the Environmental Defense Fund. Last bit from the New York Times is that these leaks that cause a lot of this damage are tough to pinpoint where they're coming from, but my next guest also has something to say about that because he is helping to pinpoint those leaks. Stephane Germain from GHGSat in Montreal, welcome.
Thanks, John. It's a pleasure to be here.
GHGSat, so all that doom and gloom that I just read, methane leaking out of various places. You can tell us what those various places are and how GHGSat is finding them.
Well, it's a grand ambition. It's I love the title of this webinar. It's a bit grandiose. Yes, I guess at the end of the day, what we're trying to do is help the fight against climate change, and I think that's really inspirational. And so we are absolutely finding emissions all over the world, and we were designed from the get-go for finding emissions all over the world and pinpointing them, as one of those quotes says. So it's been a very exciting time. I'm very fortunate to be part of this adventure and have a great team working with me to do it.
Let's get the family part out of the way. I love the names of the satellites. So I decided to entitle this GHGSat and Family Save the World because, of course, those names do come from family. Explain that.
Yeah, so we decided, and this goes right back to the beginning of GHGSat, that we wanted to name the satellites after our children so that we'd remember why we're doing this. So we've named each of our satellites after the child of, and it just turns out each of those are children of our science team members, 3 different science team members. So Claire is the daughter of our science team lead, and the next 2, Iris and Hugo, are also our children of our science team. So we want to keep up that trend. It's a way to just remind us of why we do what we do.
If I'm not mistaken, you guys better have a lot of kids because you have, I think, 10 more satellites to go because you wanted to reach 10 or 12 satellites by 2022. Is that right?
That's right. So 10 total. And so we need to name 8 more in the near term. And unfortunately, we have lots of kids. So there's no problem. Lots of young kids too.
Okay.
So, it's fun having a young team that a lot of the team are being new parents. And so no, there's no lack of opportunity there.
I thought you might snicker when I read the Bloomberg quote, if only because they say in the last few months, there are some satellites that are helping to detect these methane leaks from industrial areas, among other agriculture, industrial areas. But you've been at this for years. Take us back to the very first one, beloved Claire, and talk about that process, getting Claire into the atmosphere.
Yeah, well, it's a classic entrepreneurial story of nobody really believing we can do it until we actually show them we can do it. And that's part of the challenge we faced, is raising the awareness around what we do and actually convincing people that yes, we can pinpoint leaks to individual facilities. So the adventure with Claire started with a spark, an inspiration, when the cap and trade scheme was announced between Quebec and California, realizing that a value on a ton of carbon would motivate industrial operators to better want to understand their emissions. So that was the spark. And then we spent quite a bit of time putting together the initial proposals, putting together the initial technical solution, and talking to customers. And really, the customers drove everything. We wanted to make sure we weren't pushing a new technology on the world. We wanted there to be a real demand pull. We wanted to make sure that people would actually buy this, because this was always from the get-go going to be a commercial undertaking. And there were a lot of fits and spurts and a bunch of stories around that, I got to tell you. But at the end of the day, it all worked out. We launched Claire in 2016. We were down to fumes, I got to tell you, as a business at that point. We were really, everything, and literally everything, was riding on Claire. And Claire proved that we could do what we said we would do. And that led to new investments, 2 more satellites, which we finally just launched. I say finally because those were a little bit delayed because of a whole bunch of adventures.
Yeah.
And now we're really rocking with another 3 satellites on order, and we're planning to order another 5 before the summer. So things are pretty exciting.
So like a 7 year overnight success is basically the way it is.
Yeah, that's the classic entrepreneurial story, right? It's
yeah.
Yeah. So as that quote says in Bloomberg, for the last few months, wow, we've been seeing it for a lot more than a few months. But that's part of the awareness challenge. We're a little company from Canada that needs to be known worldwide by huge customers and international agencies and governments. I mean, how do you do that, right? It's a big challenge. So I take the positive in every one of those statements. As long as there's more people seeing us and more people being aware of us, I'm good. And we need to keep accelerating that.
Yeah. Are you finding now that, you were kind of the only kids on the block and you were scrabbling to get it together? And now I saw, and I believe you quoted as well, this article from the New York Times the other day on your LinkedIn that talks about competition is now starting to rise for you. Or do you take the mindset of competition is a good thing because it just makes us work and drive harder? Or how do you look at these new people on the block?
Competition is a wonderful thing. I think it hones all of us to focus on what customers want. When somebody else comes up with an idea that we should have had first, it's a real kick in the pants to remember that there's a lot of other really smart people out there, and we've got to be the smartest and fastest of them all. So I find it really invigorating. And I know a lot of people on my team do too. We really, as a team, take pride in the fact we're the world leaders in this. We're literally the only people in the world doing this right now. And we have a huge first mover advantage. We want to keep that. And we want to reap the value from that and have the impact from that. So it's a great motivator.
Yeah, we'll get we're going to take a look at some stuff from your Twitter feed in a bit too, to show people how you're getting your name out there. And I highly recommend following a GHGSat model for getting your name out there. If you're, as you say, a little old company from Montreal and getting known worldwide. It took me a minute to kind of make it click in my head how you were a business. I knew that you were trying to find methane leaks, stop them, it helps the environment, etc. But it took a while for me to click into how you're making money out of it. And it has to do with which I think is genius, which is showing these companies that might have these problems, these leaks and such, that they can actually take that product from a mistake or an error or an oversight and turn that into money for themselves. So could you explain that?
Yeah, so it is a challenge to get that into people's heads. I mean, I'm not surprised it took you a minute to see the business angle to it. But there's always been an opportunity here because governments have always, well, to date, designed their satellites. And remember, there's been satellites doing atmospheric monitoring for years. So they've always designed their satellites to look at the whole planet all the time, to inform global climate change models. None of them have really designed something specifically to look for individual facilities. Now, it turns out with a whole bunch of tricks and jumping through hoops, you can sort of scratch at the edges of that. But even the latest systems, like the latest one announced, Sentinel-6 now from the European Space Agency, CO2M is the other name for it, even that one will have only 2-kilometer resolution, whereas we have 25-meter resolution. So, 2 orders of magnitude better. And the difference is because they have a different mission, again, that's more attuned towards the global mandate of seeing the entire planet all the time. So that creates an opportunity for us. It allows us to offer a service to customers who at the end of the day need actionable information. It's great to get a pretty picture, and we've got great pictures. Look at Pulse on our website if you want to see a pretty picture. It's a map of the world of concentrations, but you can't really action anything with that. So if you're an operator and you want to limit your carbon for a couple of reasons: one, because you want to have you want to limit the impact of carbon pricing; two, because you want to respond to shareholder pressure about mitigating and reducing your overall environmental footprint; or three, because you actually want to make more money because you can sell your gas. You need actionable information. You need to know where your leak is, how big it is, which one you're going to prioritize. And you need that delivered to you in a way that it fits into your operational systems. And that's not what the government systems do. You definitely need some translation. And even philanthropic ventures or advocacy ventures like MethaneSat, for example, which I'm a huge fan of. I think it's great. They're philanthropic at the end of the day. They're all about making data available for free on a global scale. And so there has to be some interpretation. Our goal then is to be the one-stop shop for all of that, in addition to using all of our own satellites with our own unique view of the world.
Where do these leaks come from? I see leak this, leak that. I mean, is someone leaving the door open somewhere? I mean, are we talking about, how big are we talking on these leaks on a magnitude of however you want to put it?
Well, they really range a lot. So one of the more interesting statistics I've seen is there's all kinds of studies across the North American oil and gas system. And by the way, let's keep in mind that methane and carbon dioxide, there's tens of thousands, if not hundreds of thousands of sources all around the world. All right. So oil and gas is a particularly important segment. And I'll talk a lot about that because it's really what we consider our business beachhead. It's the first market we really want to nail. But there's a lot of other opportunities. But speaking about North American oil and gas, if you look at the stats, 95% of the sources are responsible for less than 10% of the emissions. So those kind of sources and leaks are like flanges or valves that are leaking a little bit, or things that haven't screwed on tight enough and they're leaking a little bit around a gas plant. And they're important, don't get me wrong, but that's 95% of the effort for 10% of the total emissions. What you really want to do is find the 5% that are responsible for 90% of the emissions. That's what we focus on, because we're never going to get down right next to a flange to find a leak. So the kind of leaks we see there are things like storage tanks, believe it or not, where a hatch is left open because there's been an inspection and they didn't close the hatch properly. Or there's a valve that's broken. All right, so a pipeline valve for some reason is rusted or something, and finally because of the pressure has cracked and is releasing methane. Or it might be a broken compressor. Or actually, probably most nefarious of all, nefarious is maybe too strong a word, but is the things they call flares, where a flare is basically when there's an overpressure of gas or too much gas in the system. They'll put it out to this stick, which is like a Bunsen burner, which is a few hundred meters away from the main facility, and they'll light it, they'll burn it. The idea being that it's better to burn the gas and produce carbon dioxide than it is to vent the methane and just let it go to the atmosphere as methane, because of what you cited earlier, that the greenhouse gas warming potential of the methane is much more significant than the carbon dioxide alone. However, if the Bunsen burner goes out, then they're just letting this stuff vent. And we see a lot of that around the world. And that's really bad because it's so easy to fix. So there's a whole range of things.
Yeah, I mean, it sounds like in those cases they're just taking the lesser of two evils and now you're showing them a way maybe you can make some money out of this. I mean, ultimately, you'd like to see them capture this stuff, would you not?
That's right. That's right. So a great example is landfills. All right. So landfills have, in most Canadian cities, have gas capture systems. Why? It's because they can actually make money. That's yes, and it's also environmental, but it's because you can take that gas and you sell it into the local gas system, or you turn it into electricity for the local site or neighborhood. So you can actually save money by not buying electricity or put it into the gas system. Brilliant,
There's
right?
it,
Win-win all around.
it sounds like a great idea, and it sounds like you're making a lot of headway with it. If you're putting satellites into space and you're getting, customers are you're generating interest. Let's get into that a bit. I mean, how much has it changed from, I guess Claire changed everything, because you're knocking on the door saying, here's what I can offer you. And I can show you where these leaks are happening. And now you can make money out of it. And they're like, whatever. And then now you show them pictures from Claire, and now you're showing them stuff from Iris and Hugo. And they're like, oh, well, if you can show me exactly where it is, so I don't have to spend money finding it, apart from paying you guys at GHGSat, right? I mean, you're saving the money that way. So what's has the reception been getting better year on year because of this?
Absolutely, and part of that acceleration in interest has been just in the performance we've been able to demonstrate with the satellites. So Claire was enough to prove that you actually could do it, and that people's eyes popped open and said, okay, now this is getting serious. But the performance from Claire was not good enough to be actionable down at an operator level, like in the Permian Basin in Texas or in the Montney in British Columbia. So with our next two satellites, though, Iris and Hugo, now we're at a level, and we've proven that we're at a level where, yeah, they need to know this information, and they can action it. They can, once they know that there's a leak there, they will send out a team. And the best in class are companies that tell us, as soon as we get your data, within 48 hours, we have a standard, a service standard, that we will go shut down anything you show us within 48 hours. That to me is, music to my ears, both from a business point of view and an environmental point of view.
Who did you go after first? Did you stay in Canada? Did you go worldwide? Did you go after the small fish? Did you go after the big whales? I mean, what was your business sense of how you can make this work?
So it was to some extent serendipity. So I started right at the very beginning. As I said earlier, I wanted to make sure there was market pull. I don't want to push a technology on the market. I want to make sure people would buy it. So I went to Canada first, and just because I thought it would be easiest to talk to other Canadians, and I started by talking to people in Calgary. And I was going around various people, networking, getting to know who's who in the zoo with regards to environmental monitoring. And finally, I said, I'll just take a chance here. I'm going to go right to the top. And I got super lucky. I literally had the CEO sent me to the senior vice president of sustainability, who loved it. And she sent me to a guy who wound up being our best customer for about 5 years. And, in the oil patch, it's a big world, but it's a small world. Then they all know each other. So he told two friends, and then they told two friends, and they told two friends, and things really snowballed from there. We also had a launch customer with Hydro-Quebec for hydroelectric reservoirs, and that led us to other opportunities as well. But the real kicker was the one in Calgary.
Yeah, I hear it a lot too, for the audience listening, and maybe you'll back me up on this because of that anecdote, but don't start small. I mean, a lot of times if you aim high, you can hit early sometimes, and it can really get you moving.
Absolutely.
A real shot in the arm. I wanted to read this one. This is an interesting story. Again, I don't know why I kept on following the New York Times. Maybe they just do a really good job with their environmental coverage, but this is a quote here, from Paul Tullis at the New York Times, quote, last year, GHGSat spotted by accident a gas cloud in Turkmenistan, so large that it rivaled the 2015 SoCal gas blowout in Southern California for the distinction of the biggest known methane leak. Goes on to say, since then, GHGSat has been working with scientists at the Netherlands Space Research Institute, which helped develop a wide-angle satellite spectrometer called the Tropome. Quote, every couple of weeks, they give us a list of hotspots they found, and then we go take a look with finer resolution, Mr. Germain yourself said. So let's talk about collaboration. So you've done well on your own, but you can't do it alone because obviously you need customers, but you probably can't do it alone either because you might need some partnerships. So talk about how those developed.
Well, collaboration is critical on a couple of levels. So first, on the industrial level of putting together a satellite that can deliver the kind of performance we need. So we have a set of partners there. And then also on the scientific level, because it's, not to be too trite about it, but this is hard. So you need some people who are world-class experts in this stuff to help you through known pitfalls. Don't learn the same mistakes again, right? Learn how to build on the lessons others have learned. So we have collaborations with universities across Canada, but also internationally, some world experts in this. So we've worked with Harvard in particular, the Netherlands Space Research Institute, ESRON. Who are the principal investigators on Tropomi, Sentinel-5P that you just referenced there. We also work with the European Space Agency. We work with NASA, and we've scratched the surface a bit with JAXA as well, because they're world leaders in this stuff. And so those kind of groups of scientists getting together, exchanging ideas, and pushing each other with new concepts, new ways of finding trace gases in the atmosphere is really important. We all contribute and we all gain from it. So scientific collaboration is really important. Maybe industrial collaboration. I don't mean to run on too long here, but I want to touch on that too, because it
saves
really
me time.
Go ahead. So right from the get-go, one of the things we decided was that we would not replicate the existing capacity that exists in Canada for doing really high-end optics, electronics, and assembly of spacecraft components. There are world-class companies and groups in Canada for that. Why would we need to replicate that? It's a waste of capital and it's a waste of time and effort. So, from the start, we went to UTIUS, University of Toronto Institute for Aerospace Studies. And I've always, and consistently over the last 10 years, pointed out to the world, everybody that'll listen, the hidden gem we have in Canada with UTIUS. They are world-class with small satellites. And that's why we've gone to them for every one of our satellites so far. And they have our latest order as well. Super competent team, high quality, and doing a great job pulling together the satellites and integrating everything. On the optics side, we have several different groups in Canada. On our latest satellite, Hugo, the payload was built by ABB in Quebec City, and they're also building our next 3. So, again, we're very pleased with that collaboration. A very strong technical team, really world-class center for optics in Quebec City that we can leverage. Why would we want to replicate that kind of capacity in Montreal when it's right down the road in Quebec City? And electronics, we work with Xiphos Systems Corporation. So Xiphos is frankly a sister company of GHGSat, so it was kind of in the cards from the beginning. But we needed some pretty high power onboard processing in order to do what we do. And so we always knew that the natural place to go for that would be Xiphos. So it's those kind of collaborations, and maybe I'll stop there because I'm running a little long.
Well, no, I mean, the reason you're going on about it is because you've been busy. I mean, I was just about to say, you've been a busy guy, you've been a busy team. What do you say to audience members, anyone watching this? And I'm not saying any are like this, but there are people out there that they think they have a good idea and that's enough. And you had a good idea, but it sounds like you guys had to work your tails off to get it out there. So, I mean, the marketing of it and the business side of it is at least, well, I guess, I mean, the science is the foundation. But
science is only half the challenge. All right. The other half, if you want a business, the business side of this is as big, if not a bigger challenge than the technology part. But yeah, I've never worked harder than I've worked in the last 10 years to get this all off the ground, but I've enjoyed every minute of it. And if there's anybody else out there who wants to do something entrepreneurial in space, there's never been a better time to do it. I've been wanting to do this since I was 5 years old, literally. And it took over 20 years of career in the aerospace business before technology was at a point where you miniaturized it and you could do something entrepreneurial with it. It didn't cost $100 million to launch a satellite anymore. Now is such an exciting time to be in the space business, to do something entrepreneurial. And that's what I tell to, university audiences I speak to. I mentor a couple of companies. I really want them to succeed because now is such a great time to do it.
It's great to hear you say that, because honestly, it's been a year of, boy, this sucks, right? I mean, everyone is just down, and there's lockdowns and they can't do things. And there's been, let's face it, I mean, all kidding aside, tons of layoffs too. So there has been a lot of doom and gloom in the air, but to hear you say that this is the most exciting time to be involved in space is really cool. I'd like you to expand on that a little bit if you could.
Yeah, well, there's always a great big asterisk next to any comment when it comes to the pandemic. I mean, it's a pretty unique
Sure.
circumstance, but I would say that things, certainly for us, things have not slowed down at all in the last year. If anything, they're accelerating. And for most people I've spoken to, that's also true. I think other than challenges around manufacturing and supply chain, which I think are largely under control now. People have learned to adapt. I think the industry is charging ahead. So if you just think about the type of business opportunities that are developing, and start there. I'm an engineer by training. I love technology, but at the end of the day, if you need the business to need, or the customers to need the technology. So if you start there, there's just such a growing awareness of what satellites can do in Earth observation. I think there's also a growing awareness of space as a new domain for trying new things that can be helpful down on Earth. It doesn't have to be Earth observation. So, there's some more futuristic ideas like space manufacturing, space mining that'll take years to develop. But it takes that kind of vision now to have those things come to fruition, in a reasonable period of time. I think there's opportunities with, the governments, both in Canada and internationally, wanting to go back to the moon, wanting to, entrepreneurial opportunities to go to Mars. There's so much stuff out there right now, and the space economy is growing to meet the challenge. So again, I can't be enthusiastic enough about the opportunities in the near term for all of that.
No, I love your enthusiasm. I think it's great, and I think it's a great thing for Canadian space too. If anyone's just joining us, don't forget in the chat window, please drop. I see a question there from Sean. Thanks for joining us again today, Sean. Go ahead and drop us a question there, and I'll make sure to feed that to the CEO of GHGSat, Stephane Germain. I have a couple of things I wanted to show you here. We're going to go through. I was saying when we were off camera earlier that I really like your social media and the way you market yourselves. I think it's fantastic. So I'm going to share the screen here really quick. Oh, is that the one? Hang on a second. And share a screen with you and show you some of your tweets. Who's in charge of that anyway over there? So I can give them a shout out.
We've brought up a couple of new people to our team recently. Mika and Savannah, they're doing a great job.
The Savannah, I talk to her often on the email, so she's doing a great job. Here we go. Let me call this up really quick, and you can see that, I think. And so here we go. This is released yesterday. GHGSat C2 Hugo has successfully delivered his first light image, the satellite's first image of methane plume. And I believe this is you, Stephane, saying that the speed of this result is exceptional, and we're very proud to have Hugo detecting emissions within its first week in orbit. So that picture that we're seeing here, is this what the client sees? Are you sending this to someone and telling them about something, or what are we looking at?
That's exactly the kind of thing the client sees. And so what you're looking at there is a false color representation, like a heat map representation of methane that's coming from an oil and gas facility. So the wind, if you can imagine, is coming from the bottom right of the image there and blowing towards the top left. And you see that there's actually probably two sources in that one facility, one that's a bit more to the left or the west, and one that's a bit more to the right. And so that, for an oil and gas operator, first of all, the fact that we see that at all should be a great big alarm bell, because that should not be coming from that facility. I mean, you shouldn't have emissions of that size. So we've been in touch with this operator. I mean, this image is what, 4 days old, and the very next day we were in touch with the operator of the site in Asia, right, which is a feat in itself to have a network where you can find the operator and get in touch with them that quickly. They are aware of this, and I'm very confident that this will be shut down within days. And yeah, so what we give to customers are images like this so that they know that they have a leak. And then we quantify it. So we tell them how big it is as an emission rate. And then we'll also give them, if they want it, all the data behind this, so they can analyze the shape of the emissions, the shape of the plume, and any other information they'd want to extract from there. Like they might want to try to analyze exactly what part of the facility it came from.
Excellent. I've got another one for you here. By the way, I don't, if Kanye West has done something recently or something and it appears in the right-hand margin, that's not my call. I just, Michelle loves when I tune into the live stuff. She's always on pins and needles, but we'll go on to this next one here. GHGSat, congratulations. Go Iris. We're going back a bit. I had to feel for you because I believe Iris was supposed to be launched in June. And then it was a long wait.
2019.
Yes, like
oh no, well, hang on. No, there's a whole story behind this, Sean. Okay, come on, you humor me for a minute. I got to tell the story because this is sorry. We were originally supposed to launch in the summer of August of 2019, and then in July of 2019, there was a horrible accident. The Vega before ours, Vega 15, had blew up. All right, so unfortunately, the European Space Agency went into full root cause analysis, went through a very diligent process of trying to understand what went on, and they finally figured it out, and they fixed it. And so by December of 2019, we were getting signals that they were ready to go again, and they set a date for, you guessed it, March, right at the beginning of something that happened in 2020. Yeah. So early March, we're all sitting there going, oh no, is this going to affect the launch? And for the first couple of weeks, people were saying, yeah, that's not a big deal. It's going to stay in China. It'll stay localized. It won't be a problem. Well, we all know what happened then. So March, we were shut down and delayed. Everybody was brought back from the launch site because of COVID. And then they announced, you know what, we're going to try to get back into business in June. And we were thrilled because we were sure that it would be longer than that. But June, we sat in the launch pad for like 10 days. The rocket was fully fueled, ready, prepped, ready to go, sitting on a launch pad like you see there for 10 days. And they wouldn't launch because of weather. And it was all related to high altitude winds. And we were all like, I'd never paid so much attention to high altitude winds in my life, trying to figure out what the heck was going on. After that, they said, no, well, they said, we'll roll you back in and then but it looks like the high altitude winds are going to be bad for 2 months. We're like, what the, seriously? How could the weather be bad for 2 months? I won't bore you with all the details, but suffice it to say we got moved to August. Well then, so we're scheduled for August and we're again ready to roll out to the launch pad, and there's a typhoon over one of the ground stations. So we couldn't launch. So we had to get moved again. So, we were, all the jokes were going anyway. So finally, September 2nd, we launched and we were absolutely thrilled. So sorry for the big, long story, but this is
I was with you all the way because I've forgotten the 2019 stuff, I guess, because I've forgotten what life was like before 2020, but I do.
It's all a blur.
I do distinctly remember March, and then June. I remember June big. There was a lot of waiting in June, and then it was like, okay, maybe August. And then finally, as you can see here, September 2nd, and their Iris is going off into outer space. What do we have here?
And as it turns out, we kind of threaded the needle on that one because unfortunately, the launch after ours again had a failure. So
really, I didn't know that.
Yeah. So thank my lucky stars on that one.
And by the way, from a business point of view, I mean, I don't know how much you want to get into or whatever, but is it like, are you paying money the whole time that thing's sitting there waiting to go up? I mean, is there like,
we're not making money. That's the key point, because that satellite's a revenue generator for us. So no, we're not paying extra money, but yeah, it was painful.
Yeah, if you're not making money, you're losing money. Here we have, this is from your Twitter feed. Again, I highly recommend following GHGSat on Twitter. And I think this is a big part of the social media, and the online aspect is a big part of what Stephane was referring to earlier with getting the name out there, no matter what city you're from. So Hugo is designed to deliver the same performance as Iris and marks the ramp up of capacity to measure more sites more frequently across the globe. So Hugo, where is Hugo in this picture, by the way? Can we
Hugo,
see?
yeah. Hugo's at the front of the roller coaster. Hugo's right at the very, very, very top in the middle. So if you
Very
go
right
follow
here?
nope, keep going see the cylinder in the middle? Yeah, that thing.
Yeah.
You see 4 quad packs there, and we're the thing that's kind of sitting sideways on top of those quad packs.
Oh, sweet.
Yeah, the
Okay.
solar cells you see there, that's us. That's Hugo.
Nice. And
So
this is the SpaceX Falcon 9 rocket.
that's right. Yep.
Okay.
So you can see the fairing on the left there, that the one half the fairing that they'd close around the whole stack of satellites.
Yeah.
So I love this shot because it just shows you the complexity of what was going on for this launch. 143 satellites, and yeah, we were right at the front of the roller coaster. It was a lot of fun.
Excellent. Very cool. And let me ask you. So we've got Claire, then we've got Iris, then we've got Hugo. They do stuff independently, but they also do stuff in tandem. Is that right?
Yeah, so we will, for the same customer, use all 3 satellites to provide measurements of their facilities. So they work together to provide the capacity our customers need to have an actionable set of data.
Okay, awesome. Let's see what we have here, what I called up. Okay, here's a close-up of Hugo with the 100 times higher precision than other satellites. You want to talk a little bit about this?
Yeah, so from the get-go, I'll never forget, in 2016, I was sitting, I think it's, one of the joys of being a small business launching satellites, you have to raise money, and a lot of it. So I was sitting at a venture competition, and they have these little, Dragon's Den kind of things where you sit in front of a panel, and the 3 judges are all venture capitalists, and they're all, giving me the stink eye, asking me questions. Yeah. And one of them looks at me at the end of the pitch and says, so let me get this straight. You're saying you can see things that are 100 times smaller than other satellites at 100 times higher precision. And so you're telling me you're 10,000 times better than NASA? And I said, well, yes. And that guy was my first source of external funding. So really? He gave me millions of dollars. And so I was a great Dragon's Den kind of moment.
That's awesome. And hey, you had the stuff to back it up. If you're better than NASA, you're better than NASA. What are you going to do, right? I mean, it's not your fault.
You got to put it in perspective, right? Of course, we're not better than NASA. NASA's on a whole different class. But for what we do, yeah, we are. But we're in a tiny little niche for the space business.
Yeah, so far. I think you guys are doing great. What do we got here? Oh, here's the video. It might be a little hiccupy on the other end. It plays okay for me on this end, but this is the rocket going up. That must be quite a moment. Describe that.
Yeah, it's definitely a butterfly moment. So everybody goes quiet. We had the whole team on Zoom together, and we had our partners. So we had ABB, SFL, Xiphos were all there with us as well. And we're all pretty much like glued to this and biting our fingernails.
Yeah.
It was a lot of fun because once we got past the initial minute or two of, the critical stages of the launch, then we're waiting for the deployment, which is kind of fun. And we actually do see ourselves like an hour in or so. We kind of see a little hazy thing go ploop, and that's us. And then we got to see a live first contact with the satellite, which is a lot of fun. That obviously wasn't public, but it's we put it all in front of the whole team, so everybody can watch, and can tell you the guy who was doing the manual connections to the satellite was a little nervous of all the people staring over his shoulder, but he did a great job.
Oh, no pressure. Okay, and here's one from SpaceX themselves. They've got a couple of still shots here. What's it like? I mean, so there's tons of companies putting stuff into outer space, but with a lot of thanks to their head honcho and stuff, SpaceX has certainly captured the imagination right now. Is there a certain cachet to being on a SpaceX rocket?
Oh, absolutely. It was funny because we've been on a Indian rocket, we've been on a European rocket, and the Europeans tried hard to create some social media and some excitement around it, but it's just on a whole different order of media attention when you go on a Falcon 9, especially when it turns out that this is a record-setting Falcon 9, right? You've got all kinds of people following this. So it was a lot of fun.
Yeah, I'll bet. Have you ever met Elon Musk?
No, I maybe we will one day, or I will one day, or the team will one day, but not yet.
Yeah, that'd be cool. Okay, what do we got here next? I've got another one for you. So here we go. This shows it's either your crew or someone's crew, but somebody is handling Hugo. Talk about this a little bit.
Yeah, well, the guy who's peering underneath is one of our team guys, that's for sure.
Okay.
So actually, you know, I'll mention him, Frédéric, who spent his Christmas, all right, between Christmas and New Year's, down at Cape Canaveral, doing this kind of stuff. So thank you, Frédéric. You know, it was a sacrifice and much appreciated. But yeah, so this is a team with a couple of NanoRacks people. So Frédéric with a couple of NanoRacks people doing the final checkout of the satellite. With SFL, I should say that the guys at UTIS, the Space Flight Lab, are on the phone and online as well, watching every step of this and making sure everything was being done properly. So yeah, this is the last final checkouts of the satellite before we put it on the rocket. And it's always a stressful moment. This one in particular, but I won't get into the details of that.
Okay. All right. Got another one for you here. This is the one, I know you hate this one, but
Speaking
I
of
like
stressful, yeah.
So
Yeah.
it's probably a little hiccupy on your end. I mean, it's a little smoother on mine, but this is the vibration test where I always kind of crack up because I'm like, these satellites have a better social life than I do or something.
Oh, wow.
But you go ahead and describe what it's like to do this.
I hate this test with a passion because we got a lot of money in that thing right there. And this is a highly precise optical instrument that we're like shaking like a dog, you know, this thing is like not what you want to be doing. And so it all comes out okay. And
I guess, I mean, this is obviously how is it going to behave when we put it on a rocket and it's vibrating like crazy.
Oh, that's right.
That
yeah. I should say, for those who are not familiar, this is a vibration test. It's only one of 3 axes. We do it on all 3 axes, and then we do different types of vibration tests. This is meant to simulate the ride on the rocket. So you want to know before you put it on the rocket that it's going to survive.
Sure. And is this this video being done right here? Is this Montreal? Then you send it down somewhere, or is this down
no,
at the
facility?
This
is at UTIS. This is in Toronto at the University of Toronto.
Okay. And then how does it get down to where it's got to go to get on the rocket? Like, I mean, does somebody put it on the cargo, like a seat beside them? Or do they just?
You'd be surprised. It went down on a dedicated truck, but it's you know, it's just a really nondescript little panel truck that, you know, if you saw it going down the road, you'd think it would be some furniture mover. But it's our little baby in there.
Wow. Okay. From
Toronto
the U-Haul to the Falcon 9. All right.
I had visions of this thing sitting in a motel parking lot, you know, flipping overnight with a little padlock on the back of the truck, right? Some junker coming along wondering what's in there.
All right. Good stuff. We'll get off this one because I know you hate this one. Let's go. Got one more here. This is GHGSat. This is from NanoRacks. And again, so as we were talking about earlier, we're talking about the collaboration. We've got NanoRacks listed here, ABB, SFL, Xiphos. We've got Sinclair, all to come together on this kind of thing. Let me see if I can just open this one up.
Yeah, and there's also a story behind NanoRacks I should talk about briefly, and it relates to the Falcon 9. But we were originally scheduled for Hugo to be on a Soyuz. And it's another pandemic story where at the beginning of the pandemic, we were basically told, we're not taking any more payloads on this rocket because you know, the primary has to go, and we're not going to mess around with any secondaries given the pandemic. So, you know, we got punted. And so we went looking, and it turned out NanoRacks had a slot left in their port on the Falcon 9. And we decided, let's go for it. Let's get NanoRacks, great company, great reputation. They have obviously been around the space business for a long time. You know, surely they can do it. And they did. They pulled it off.
Excellent. And where are you on here? So we were at the top before, so somewhere up in here?
On the top right there. Yep. That's us.
Awesome. And this is, so it was 143, right? So 143 different spacecraft. And when I think, you know, anytime someone hears spacecraft, they think of the USS Enterprise or something, but we're getting down into like, you know, thumbnail size stuff now, aren't we?
It's actually, you know what, this launch, part of the reason I really enjoyed this launch is because it was a who's who of the new space community. All the companies that have really pushed the edge over the last 10 years, literally all of them were on here. So Planet was on there. That we have Capella's on there. We have Swarm is the one I think you're referring to, the guys who have these tiny little satellites.
Yeah.
For IoT. Kepler from Toronto was there as well. They had satellites on here. So it's just really fun. It was kind of like the ultimate ride share, as far as I'm concerned. It was a lot of fun being on, and I felt privileged that we were on with all those people.
Yeah, that was a big weekend for Canadian space. I mean, there
It
was a lot
was.
of action going on there.
Yeah, I think we launched 9 satellites between us and Kepler all at once. So
Yeah, that's
great.
excellent. We also, and I just wanted to point out, because he's a great guy. I mean, if you're not involved in social media because you think it's not worthwhile to you, I mean, space people are on Twitter hardcore. It can be a lot of fun. I just like rocket people. Okay, that's hot. You know, like these these are the pictures that the space folk like, that they really appreciate those. And I just wanted to call out one more, because he's a really great Twitter follow too. Is Tori Bruno from ULA. And I just, someone asked the amount of greenhouse exhaust that the aerospace industry produces compared to literally anything else is tiny. And he says minuscule. So what you're up to is a good thing and a net positive for the planet. So I'm just going to stop the share and come back and talk to you for a couple minutes. I see, whoa, we've got a few questions here now. So that's good. So let's, after going through your family photos, let's have a look at some questions here. So we've got one from Sean. Thanks, Sean. Looking at this amazing map on Pulse, and Pulse you can find on the GHGSat website, it strikes me that none of this map is streaky like you'd expect from wind. Why is that? I imagine it has to do with the type of imagery, but I'd love to know more.
So Pulse, first of all, for those of you who haven't seen it, it's a map of concentrations of methane worldwide. Now, it is a monthly rolling average. So that's the answer, Sean. It's so if we were just on any given day, yeah, there'd be gaps everywhere. It'd be streaky because of clouds, weather, wind, whatever. But because we take data from over a month and average it all together and actually perform a bunch of other manipulations with it to get super resolution, for example, we get an image over virtually every part of the world. There are still some gaps. So, for example, over high altitude, sort of the Rockies, for example, or the Himalayas, you'll see there's gaps. And so it's not perfect, but it does a fairly good representation of methane over the world because of that monthly time average.
Excellent. Again, if you have any questions, we've got a few minutes left, so go ahead and throw them in the chat window. I'll make sure that Stephane Germain, CEO of GHGSat, gets the question. Let's see here. From Aravind, he says, how important is it to convert insights from emissions data into a software product rather than just show pixels? Will that be GHGSat's go-to market strategy? Or do you see enough demand for pixels from customers, institutional and commercial? That's a little beyond me, but maybe you get that, Stephane.
I do, and it's actually a very important business point. So
okay.
There's not a lot of people who know what to do with moles per meter squared per pixel, which is the native output of our satellite measurement.
Okay.
It's like a concentration per pixel. So there are some, and there's definitely a market for the imagery and the pixels alone, and that's more the traditional Earth observation type customers. The vast majority of customers couldn't care less about moles per meter squared per pixel. They want to know, where's my leak and how big is it? And so absolutely, you need to translate those pixels into that information. It's the old adage of, you don't give me the data, give me the information. So it's driving those insights, which is important. So I actually see our business as having two sides. One side of the business is all about generating the measurements. The other side of the business is driving to insights and delivering to our customers the information they need in the format that they need it, which is also really important because, for an oil and gas customer to be able to use the data, the team on the ground who's going to do repairs on a daily basis it needs to get to them somehow. So how do you make it easy for them to get it? So there's a whole other side to the business, which is what we like many other people call analytics. And you want to talk competitive? That's rapidly competitive. We fortunately have a really good up in that we have our own data set nobody else has, but still, it's a really, really rough and tumble part of the business.
Interesting, very interesting. Next one here. What do we got here? Follow up from Sean. Follow up to my question. He says, how often are you imaging any given point? I imagine this frequency is increasing as you get more satellites in orbit. And sure enough, you're going to have, I believe, what is it, 10 by 2022.
Right.
So yeah, talk about that.
All right. So each satellite can see any point on the surface of the Earth. Well, not every point, but any point. It's a very important distinction. Approximately every 2 weeks. So with 3 satellites, it's roughly linear. So if we wanted to see, my house in Montreal as many times as we could, right now we could see it every 5 days roughly, weather permitting, right? Because then if there's clouds, we'll miss one of those opportunities. With 10 satellites, again, roughly linear. So it'll be roughly every 1 to 2 days. But part of what we do is balance revisit versus coverage. So most customers really don't need to see their facility. I don't need to see my house every day, right? My oil and gas customer doesn't need to see their well every day. So what's more important is they want to see all their wells maybe once a month. So instead of revisiting to the same place, we go look at different places and increase our coverage with the number of satellites. And we balance both of those very dynamically. Literally every day, we're replanning our capacity.
Okay. I got a question here sent direct message. Somebody wanted to stay a little incognito. How helpful was the Canadian government and its resources to meet all the international private and government contacts or maybe contracts? Did the government have a place to go to meet all the environmental contacts in other countries? I guess talk about, I mean, we spent a lot of time talking about private enterprise. Bring it back to maybe some public affairs if you want to.
So Canada is one of the best places in the world to do R&D and
Nice.
to start and develop the technology for our business. Right. I think it's a bit cumbersome, like any government program, but I had somebody tell me there's something like 500 different government programs that can offer money for our different stages of R&D. We've certainly participated in at least a dozen. And that was a really important part of what we call non-dilutive funding. So it's a way for us to raise money without having to sell equity. So for example, me as a founder, I don't have to sell my shares in order to raise money. So Canada's fantastic for that. Where Canada starts to fall down is on the gap between once we've developed the technology and commercializing it. Because Canada's really cautious around World Trade Organization rules of not subsidizing companies beyond the R&D stage. And I get it, but I can tell you that, you just look south of the border for an example. Every single space company, it seems, south of the border, certainly every major one that is at our stage of development, has a huge government contract, whether it be from NOAA, NASA, or the military. We have none of that, right? And that's maybe not, it slides by WTO rules because it's for national security or some other exemption related to research, but it's still supporting commercialization on a massive scale, right? We don't do any of that here in Canada. So Canada really needs to up its game on accelerating commercialization. There's in entrepreneurial circles, there's always a frustration that, before any Canadian company makes it really big, it'll be sold to an entity south of the border. Well, part of the reason for that is because we don't have our own domestic market charging hard to make those companies grow in Canada and create jobs in Canada. That's starting to change, but like all governmental things, it's slow. So, the positive, fantastic place to start. And it's, as I said earlier, if you want to start something in the space business, Canada's an awesome place to do it. It's worldwide. It's a great time to do it. Canada's a great place to do it. More challenging on the commercialization side.
Well, we just did talk about how it was a great weekend for Canada that weekend, but we also mentioned that it was those things were riding on an American rocket from SpaceX. So
Sure.
Where do you see, where is there a place then for, I mean, I would think there is, if there's that many riding on a rocket down there. Is there a place for a Canadian rocket to lift off from Canada with Canadian satellites on it? Where do you see that in the future?
So I'm not going to be popular for saying this, but I'll be blunt. I think the latest statistic is there's like over 140 companies worldwide that are trying to build a launcher and be in the launch business. Less than 1% of those companies are going to well, 1%, maybe 2% of those companies are going to survive. Right? It's a very small number is going to survive. And I don't see Canada having a unique competitive advantage in the launch business. So we don't need to be all things in all parts of the space business. We should pick and well, not the government shouldn't pick, but I think entrepreneurs and the business and the science community should pick the areas that we want to dominate in and do really well in those. Now, there are outliers out there. It may turn out that somebody's got something really, really, really good in the rocket business and they should be differentiated and they should do well. Awesome. I hope I wish them all success. And frankly, that's what we are. Nobody would have picked environmental monitoring as a business that should succeed if people were allowed to pick for us, right? But we saw the opportunity and we decided to make a go of it, and so far so good, right? So you can still do your own thing, but I think should there be a launch business in Canada? I'm more skeptical.
All right, and I like the blunt. Keep the blunt coming. I think you're a great ambassador for Canadian space. I like the way you frame things. You're enthusiastic, so I think people want to hear what you have to say. Another question here for you from Francis. Thanks, Francis. Hyperspectral imaging was introduced with Claire. How important is it to get as much of that high resolution data down to the ground as possible?
So first of all, thank you for saying that hyperspectral imaging was introduced, but actually that's not technically correct. Hyperspectral imaging has been around for a while.
I was just pumping you up and now you're going to be all humble.
Well, okay, I'm going to be humble about it, but we did do our own unique version of hyperspectral imaging. Let's be clear about that, because we had to do something really funky and patent it in order to be able to do what we do. And it is hyperspectral imaging. But anyway, to answer, I think that the gist of the question is how important is it to get all the data down? Because hyperspectral is notorious for generating just reams of data. And so what do you bring down? So we do bring everything except for cloudy scenes down. So we do a little thumbnail selection up on orbit. We'll take all the images on orbit. We'll look at the ones that are cloudy and we'll say, you know what, we're not going to take those. So we cut a lot of our data volume down by doing that. It's about half our observations wind up being cloudy, so we won't bring those down. But otherwise, we bring it all down. Now there's it's getting increasingly complex, and we're taking more and more images, and we're learning to add more capacity to our system. So we're having to switch to different technologies. So on our next satellites, we're going to go to X-band downlinks, for example, whereas we've been using S-band, and so the difference there is just more capacity. We were also testing an optical downlink on our current satellites. And while this one isn't going to work out, I think that there's, that's part of, you got to try things, and sometimes they work and sometimes they don't. I still think there's a role for optical communications as well, because it bypasses a lot of the issues around RF communications, which are horrifically complex in terms of licensing. So anyway, long story short, it's important we get a lot of it down. We do have the ways of doing it, but it is a complex subject.
We've got a wonderful fireside chat. Tahir says, thank you for your insights. I see that we've reached the hour, so I'm going to cut you loose so you can go back and do some more awesome stuff for Canadian space. But give us a shameless plug. What have you got coming up? Well, what's it called? Iris was coming up too, but it was delayed a little while. But what do you think is coming up in the next year for GHGSat? What are you looking forward to?
Wow, we have a ton on our plate, and it's really exciting. First of all, launching 3 more satellites in the near term, and well, actually, no, it's 8 more satellites in the near term is a challenge in itself. We're also, by the way, flying an aircraft sensor. We don't talk about that very much, but we have a whole team of people based in Calgary who lead our aircraft monitoring business. And so we're really busy with that. And the combination of both is an extra differentiator for our customers. Our analytics, I just have huge enthusiasm for turning that data into insights. It's viciously competitive, but somehow that kind of motivates me. There's an opportunity to really try to find our niche and do something. It can be really hugely impactful as well. If we can do half of what we think we can do with our data, it could just really have a significant impact on reducing greenhouse gas emissions around the world. And that's really motivating too. So, through all of that, we've also more than doubled our team since the pandemic started. So think about that. I actually haven't physically met more than half my team right now. And we plan on hiring again, probably that same number within the next 9 months.
Yeah,
So
you guys have been all over like LinkedIn and Twitter with some hiring drives.
yeah, yeah. So look,
Yeah.
it's a lot of fun. I just feel so lucky to be in a role that I've always dreamed I'd be able to do, and I'm having fun doing it with a great team. And I just look forward to doing it for at least another 20 years.
It all sounds fantastic. I thank you very much, Stephane, for joining me today to talk about this stuff. And with another bunch of launches and satellites to go up in the next year or two, 10 by 2022, I hope to have you back and we can have a chat about those and look at some pictures and talk about some good stories. So I really do appreciate that. Stephane Germain, CEO, President, GHGSat out in Montreal. And next week, if you're still on the line, and I see a bunch of you are, please join us. Eva Jane Lark from BMO. Nesbitt Burns is going to talk about how you can finance your business and your company in the space industry. That's a lot of what we've been talking about. Stephane was there 6 years ago saying it was all on the line, every last bit of it. 6 years later, they're celebrating great success at GHGSat. So the lesson of that is it can happen. So thank you very much for joining me, Stephane, and everyone else, and hope to see you again soon, especially next week with Eva Jane Lark. Bye-bye for now.